So y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause it and I'll show you how to do them correctly. So this is going to factor as x squared, and your numbers are going to be -3 and -5, and neither one of those difference of squares will factor further using integers, so we're going to leave it just like that. For a geometric sequence, to get from one term to the next, you multiply by something. What can we multiply 4 by to get 10? Well, you would multiply it by 2.5. And then 10 times 2.5 is 25. So 25 times 2.5 gives you 62.5. And so your correct answer would be D for the next term in the sequence. Okay, so we are looking at lesson 82 today. We're dealing with limits and continuity. And then we're going to look at differentiability. So hopefully you'll understand limits and continuity and also differentiability after this lesson. For a function to have a derivative at a specific c value, it has to be continuous at that c value. So if your function is not continuous, then you will not have a derivative at the value. So if we have a graph that has a hole at this c value, whatever it is, we will not have a derivative because it is not continuous right here. Okay? The derivative of your function at c is going to be equal to the limit as x approaches c of f of x minus c over x minus c. And so we're going to use that whenever we're looking for the derivative at a specific c value. If you look at these two graphs, this is just the graphical interpretation of your derivative as you approach c. It's basically going to the slope of your secant line, and as your c gets closer and closer to x, it's going to become a tangent line. And so you're just going to have your slope of your tangent line, which is your derivative. Looking here for differentiability, we do not have a derivative at this point, this point, this point, or here. You cannot have a derivative at a cusp, at a sharp point, or where you have a vertical tangent line. So all four of those, you would not have a derivative. It's not going to be differentiable at those specific c values, wherever those happen to be. So we're going to use the left hand and the right hand derivatives to determine if our function, the absolute value of x minus 2, is differentiable at x equals 2. Well, let's look at the graph of this function. An absolute value of x minus 2 is going to be a v graph. And so we're going to put it into a piecewise function. This left-hand side is going to be the graph of negative x plus 2. And that is when your x is less than or equal to 2. And then the right-hand side is going to be just the graph of x minus 2, and that's whenever your x is greater than or equal to 2. Now, if you take the derivative of these two pieces, you're going to have -1 and 1. If your x is less than or equal to 2, and if your x is greater than or equal to 2. Do these two limits match up? Well, obviously not. They're not the same number. One of them is our left hand and one of them is our right hand derivative. Since they don't equal the same number, that means that it is not differentiable at that value. So since we have a -1 for the right hand limit, or for the left hand limit, and we have a 1 for the right-hand limit. Those are different, so it would not be differentiable at 2. It does not have a derivative at x equals 2. Looking here, for what values of x is the piecewise function shown below differentiable? Well, we've been dealing with these where it's asked for it to be continuous. Whenever we had a continuous one, we would just set them equal to each other. So x squared equals 2x minus 1, and then we will plug in our x value. So 1 squared is 1, and then 2 minus 1. That didn't really help because I just get 1 equals 1, right? But it asks for differentiability. So we need to take the derivative of each piece. So the derivative of x squared is going to be 2x. The derivative of 2x minus 1 is going to be 2. And now we need to know, do those actually equal each other? Well, we plug in our 1 for our x and we get 2 equals 2. Do those equal each other? Yes. So what values of x is it differentiable? Well, we know it's continuous because we had 1 equals 1. It is differentiable everywhere because at this specific point, we know that it's differentiable because the left and the right hand limits were equal because they both equal to 2. And then it's always going to be differentiable on a continuous function here and here. So what values of x is it differentiable? For all of them. Because we have a continuous function, and at that point where those two pieces meet, it is differentiable. So for the whole thing, it would be differentiable. Okay, let's look at this one. Find the values of a and b such that it is both continuous and differentiable at x equals 1. So for the continuous part, we set our functions equal to each other. And we plug in a 1. Absolute value of 1 is 1 plus 3 is 4. And then we'd have a plus b. And so that's for the continuous function, which is what we've been doing for the past couple of days. And normally you would just pick random values for a and b, and you would move on, or you would just write a plus b equals 4. Now, for the differentiable part, we have to take the derivative. So the derivative of x plus 3 is just going to be a 1. The derivative of this is just a 1 because we're at x equals 1. So that's the positive part. And so we just have a 1 there. We don't have to worry about dealing with the negative x because that's on the other side of it. The derivative of this is going to be 2ax plus b. Think of the a, it's just a number, so think of it as just like a 3x squared. Well, you would bring the 2 down to make it 2 times 3x. Well, we have 2 times a instead of 2 times 3. And then derivative of bx, what's the derivative of 4x? It just goes to a 4. Okay? Now we plug in a 1 for our x value. And so we have 1 equals 2a plus b. At this point, you can do substitution or elimination, whichever you want to do. I like doing elimination, so I'm going to multiply this one by -1. And then I would have 3 equals -a. So a would equal -3. And if a equals -3, b would have to equal a +7. But again, you can use substitution there if you would like. But on these, you're going to have a specific a and a specific b value. You're not going to have just an equation where they have to add up to a specific number. Okay? So that's how you deal with differentiability. You start off setting them equal to each other, like you did for continuous, but then you also have to take the derivative and set them equal to each other. And make sure that they work for both of the equations you end up with. Okay? So on your homework, you do get to omit number 21 for tonight, so make sure to do that. And then we can go over any questions you have tomorrow.